All right, shoot, my video stopped in the middle while I was recording it. So let's pick up from where I left off and hopefully I can merge these together. Okay, so it should have been, did you say a 1x4x4 for the last one? All right, let's look at question 4 now. How are the dimensions related to the dimensions of each face? All right, so let's go back to our box P. All right. Remember when we said we put it together, it would be a 1x1x6, okay? So that's the 3D dimensions, 1x1x6. That's how you'd build it. Like if I was telling my husband, hey, can you cut this, make me a little box out of a piece of scrap wood? If I told him, can you make it a 1 centimeter by 1 centimeter by 6 centimeter block, he would know exactly how to build it. Okay, so how is that related to the flat pattern that could be folded to make it? Well, remember there's 6 sides. There should be a side that's a 1x1. There should be another side that's a 1x6. Another side that's a 1x6. And then all of these are duplicated to an additional other side that's the same size. Okay, so if I look at 1x1, I'd have a 1x6, another 1x6, and then duplicates of those 3 things would be my 2D shapes that I'd have on each of the sides, okay? All right, so and you can do that for any of your patterns. Like this one, I'd have a 2x2, a 2x4, another 2x4, and then I'd have 3 more of those that are the same size. Okay, so next it asks, what is the total area in square centimeters of the faces of each box? So let's go back to box P. All right, I want you to find the total area. So how much paper would we need to actually make box P? All right, so you could start by just counting, but it'd be a little faster to find the area of this. That's 1, area of this 6, 6, 6, 6, and then 1, okay, and add up those 6 areas together. What'd you get? About 26. All right, let's look at box Q. Let's find its total surface area. All right, so I've got a 1x3, so that has an area of 3. A 1x3 has an area of 3. 3x3 is 9. 1x3 is 3. 3x3 is 9. 3x1 is 3. It'd be faster than just counting each one. I could just add up those 6 areas. Did you get 33? All right, I want you to do the same thing for R and for S. Okay, so I can find the area 4, 8, 4, 8, 8, 8. Add that all up. Did you get 40? All right, and then the same thing for S. This area is 16. This is 4, 16, 4, 4, 4. Add all that up. Okay. Did you get 48? All right, so in what unit should I put on these? These should be centimeters squared. I'm trying to figure out how many square centimeters I would need to build my box, okay? All right, so how do we do this? Hopefully you didn't just count each block, but you added the areas of the 6 faces. All right, so now we're gonna see how much volume each box takes up. So I want you to take your little cube like this. This is 1 cubic centimeter, and that's how we're gonna measure how many cubic centimeters would it take to build box P. Okay, so if I were gonna try and fill box P, how many of these little cubes would I need to fill it? Okay, did you think 6? Just 1 layer of 6. How about for box Q? How many little cubes would I need to fill this? Fill that in there. How many blocks would you need? See, I just need 1 layer of 9. How about for R? What do you think its volume is? How many blocks would I need to fill box R? Okay. could you see that I could fill 8 on the bottom, and then I'd need 2 layers high of 8. So a total of 16 blocks would be needed to fill that guy. Okay, and then how about box S? How many blocks would I need to fill this? Okay, I would have 1 layer of 16 is what it would take. Okay, what kind of unit? What was I measuring those with? This little cubic centimeter. So this would need 16 cubic centimeters to fill, cubic centimeters, 9 cubic centimeters, and 6 cubic centimeters. All right, so this is going to be a little extension for number 8. So it's design a net for a box that has a different shape than box P, but holds the same number of cubes as box P. So I want you to see if you can try and make another box, okay, that would hold 6. That's not a 1 by 1 by 6. Okay, so if you got some extra paper, you could try and do that. Okay, and if you think you've got a flat pattern that you could, or a net that would fold and hold 6, but would not be a 1 by 1 by 6, take a picture of it and attach it in a classroom. Okay, so that's kind of like an extension if you've got some extra time and want to like keep your brain moving. Okay, so 6 centimeters cube, a box that's not a 1 by 1 by 6 that would hold 6 cubic centimeters. Okay, so that's kind of just a wrap up for today. We learned a little bit about surface area, the amount of area on the outside, okay, or the amount of area needed to make the flat pattern to fold into a box of a certain dimension. And we also learned about a little bit now about volume, how many cubes it would take to fill inside that box.